Okay, now to simplify how respiration works, okay, so how the gases get from the atmosphere to the cells, okay, we simplified it into 4 steps, okay, so 4 processes. So the first one is pulmonary ventilation, okay, so the air is gonna, that's supposed to be lungs, okay, so the air is gonna come in from the outside into the lungs, okay. Step number 2 is it's going to go from the alveoli to the blood. Okay, then 3 is the blood's going to carry it. Okay, between lungs and systemic cells. And then the last one is we're going to drop it off at the tissue. Okay, so 4 steps. 1, 2, 3, 4. Okay, and of course we have to break down those steps. Okay, so here's another picture, and these numbers go over like this. Okay, so 1, so the air containing oxygen is going to come in, right? The oxygen is going to go into the blood. Okay, then it's going to be carried in the blood, so we have to talk about that, and then it's going to move to the tissue, to the cells. Okay, then we're going to pick up carbon dioxide. Okay, it's going to diffuse from the systemic cells into the capillaries. Okay, then the blood's got to carry the carbon dioxide back. Okay, and then it's going to carry it to the alveoli, and then the carbon dioxide is going to be exhaled. Okay, so that's pretty, I think that's kind of straightforward, but it breaks it down, and each one of those numbers goes with a step over here. Okay, and I broke it down this way on that worksheet. Okay, now, what drives the movement of air in? So basically, it's based on pressure. Okay, now, atmospheric pressure, so if we're at sea level, oh shoot, that's supposed to say, I'm really having problems spelling today. Okay, so at sea level, the atmospheric pressure is, they call it 1 atmosphere, so 1 atm. Okay, but we talk about it in millimeters of mercury. Okay, so 760 millimeters of mercury. Okay, now, when pressure changes, this number is going to change a little bit. And gases, just like liquids, are always going to move from an area of high concentration to an area of low concentration. Okay, so it makes sense, right? They're going to move just like a liquid would. Okay, so now there's going to be pressure gradients, okay, so differences between what's in the atmosphere and what's in the lungs. Okay, so intrapulmonary is what's in the lungs. Okay, now the way that we create these pressure gradients is by changing the size of your thoracic cavity. Okay, so by modifying how big it is. Okay, and we can modify the size of your thoracic cavity using your diaphragm, okay, and your muscles, your other muscles around. Okay, now this is one of the gas laws. It's called Boyle's law. Okay, so Boyle's law is just basically saying that there is a relationship between pressure and volume. Okay, so at a constant temperature, the pressure of a gas decreases if the volume increases and vice versa. Okay, so if we increase, so we have the same amount of gas in both of these. If we increase the volume, the pressure is going to drop. So if we increase the volume, pressure drops. Okay, if we decrease the volume, the pressure that gas is under is going to go up. So inverse relationship. So the bigger the cavity is, or the bigger the space is, right, the more room there is for the particles to move around. But if we decrease the volume, okay, there's less space, and so the pressure goes up. Okay, so inverse relationship between gas, pressure, and volume. And that's Boyle's law. There aren't many laws I make you know, but Boyle's law is one of them that you do need to know. Okay, now, when we go to inhale, okay, so let's draw a thoracic cavity. Okay, so there's the diaphragm. Okay, when we go to inhale, okay, the diaphragm and the external intercostals, which you remember them, they're in between your ribs, okay, they contract for inspiration. Okay, now when the diaphragm contracts, it flattens. So this is a contracted diaphragm. Okay, and then the external intercostals are going to lift the ribs up. So you can kind of picture yourself sitting with your you're taking a deep breath and your chest cavity gets bigger. Okay, so the diaphragm contracts. Okay, so when this happens, what we're going to do is we're going to increase the volume. So that means the pressure in here is going to go down. Okay, then the pressure in here is less than the pressure out here, so the air will flow in. Okay, so the diaphragm flattens when it contracts. That's important. You need to know that. Okay, now when they relax, okay, so when we relax, okay, we're decreasing the volume. So when we decrease volume, the pressure will increase, right? And the air will actually move out. Okay, now, quiet breathing, relaxation, is passive. Okay, so no energy is going into it. Everything is just coming back to its normal shape. I hope that makes sense. Okay, so relaxation and quiet breathing, exhalation is passive. Okay, now forced inspiration. If we want to, like if you're going to, I don't know, blow out the birthday candles. All right, so you're going to take a deep breath in. So you're going to use extra muscles. So you're going to use the sternocleidomastoid, the scalenes, the pec minor, and the serratus anterior. I don't know what this is about. I don't know. Okay, serratus anterior. So we make it bigger. Okay, so we're going to move the rib cage up superiorly, out laterally, anteriorly. So the whole goal is to increase the volume. The erector spinae will also help lift the rib cage. Okay, so those are the ones that run alongside your back. So what will happen there, right, is we'll even increase the volume even more. So then the pressure drops even more, and you have a greater gradient, and the air will come in even more and faster. Okay, so here's the steps. Okay, so if we go back here, okay, so what will happen is when the volume changes, it decreases interpleural pressure. Okay, so when the volume increases, the pressure out here decreases, okay, and the interpulmonary pressure will decrease. So it's kind of like a chain reaction. So the pressure in the space in between, okay, the intrapleural pressure decreases, and then the lungs stick to that, okay, and then the pressure in the lungs decrease. Okay, so interpleural pressure, this is what's in that pleural cavity. Interpulmonary pressure is what's in the lungs, is the pressure in the lungs. Okay, so we change the volume of the thoracic cavity. That changes the pressure, and then what it's going to do is it's going to drive, the oxygen's going to move, or the air is going to move. So this is 760, this is probably 756. So not a huge difference, but it's enough that the air is going to move from a high concentration down to a low concentration until it's equal. Okay, now another thing that helps the lungs inflate is warm air. Okay, so warm air rises. Okay, so the inflation of the lungs is going to increase the warmer the air is. Okay, and that's actually Charles's law. So there's another gas law. Okay, now passive expiration. Okay, so expiration is the same as exhalation. Okay, now what happens when you die? Okay, they say you expire. Okay, so the last thing you do is you exhale. Okay, so now it's a normal, if you have a normal breath, okay, so you inhale and you exhale. You inhale and you exhale. What's going to happen? The exhale part is just when the muscles relax. Okay, so the diaphragm is going to go up. Okay, so the diaphragm, when it's relaxed, it's domed. Okay, so we say it's domed. So that's a relaxed diaphragm. Okay, so the volume is going down. The pressure is going to go up. Okay, and then the air is going to leave. Okay, then, so when everything relaxes, our lungs and thoracic cavity are actually very elastic, right? So they want to go back to being small. Okay, so the volume of the thoracic cavity decreases, interpulmonary pressure increases, air is expelled. Okay, so what happens? So after you inspire, the phrenic nerve, it stimulates the diaphragm, and it kind of makes a gradual transition so that we don't have, so that we have more, so your breathing is gentle and gradual and not kind of erratic or rough. Okay, so here's some numbers. Okay, so if we look at this, so quiet inspiration, 760 in the atmosphere. Okay, 756 in the interpleural space, 760 in the lungs. Okay, now and the diaphragm is domed. Okay, now when we go to inhale, okay, this is going to make the volume bigger. Okay, and it's going to actually change the pressure. Okay, so the pleural cavity volume increases, inner pleural pressure decreases, alveolar volume increases, inner pulmonary pressure decreases. So that means that the air is going to come in. Okay, when we go to exhale, the opposite's going to happen. Okay, in a normal quiet breath, we have about 500 milliliters of air come in and out. Now, this volume depends on how big you are, okay, so your size, your age, and your gender, okay, whether you're male or female. Okay, come on. Okay, now, forced expiration is not a passive process, okay? We want to blow the candles out, okay? So for it, we actually use more muscles. So we use the internal intercostal muscles, and we contract our abdominal muscles to blow it out. So that's going to cause the volume of the thoracic cavity to really, really decrease drastically. Okay, now, a pneumothorax, okay, this is when you get air in the pleural cavity. Okay, if you get air in the pleural cavity, we lose that negative pressure that's keeping your lungs inflated. Okay, so what happens is the pressure inside here equals the pressure outside, and the lung won't stay inflated. Okay, so the technical name for a collapsed lung is atelectasis. Okay, now it can happen spontaneously, so it could just happen. It could be triggered by trauma, okay, a chest wound. Okay, sometimes if somebody has cancer, it disrupts this too. So there's a bunch of different things that could cause a pneumothorax.